we have a few questions we'd like to ask so that we can calibrate our discussion today to better meet your needs. So there'll be a few polls that come up. Okay, it looks like the first one is, are you using the cloud today? So we just want to understand sort of where you are in the adoption of cloud computing so we can know how deep to go or how shallow to stay today. We're just waiting while a few more people answer. Okay, it looks like we're going to close the poll and we'll be able to see the results. So this is great. We've got about 40% who have been involved in cloud computing and about 40% who are beginning to explore, and then another 30% who aren't doing a lot yet. Okay, so we hope to convince you that there are great benefits to moving to the cloud. We have 3 more, and these really have to do with, have you used machine images on the cloud and how difficult they are. So first, if you've used machine images on the cloud, how easy has it been for you to create new machine images? Easy, somewhat difficult, very difficult. If you haven't used them and you're one of the folks that haven't been on the cloud at this point, just click off don't know, we're not applicable.
Dude, you're a health food addict.
Yeah.
Okay, so we've got 48% or so with some difficulties, 10% must be really experts at doing this because it's very easy, and we've got that 40% that probably haven't had enough experience to be able to answer yet. So let's okay, so it looks like it's about the same. Somewhat difficult, 30%, very difficult, 14%, and then 17% versus 10% are rating it easy. So let's keep going. We have one more, and then we'll start our webinar. And this is how easy has it been for you to execute routine maintenance. So updating software, clearing caches, or whatever else you have to do on those servers that are managed by machine images. How easy is it for you to keep those machine images up to date and those servers up to date on the latest software? Okay, this is a little more difficulty here and about the same in terms of ease of use. So what I see from all this is that there are some issues. There are some people who look like they're very good at this, and so it's probably easier for them. So let's now turn and get started with our webinar. Sitting with me here today, I have Thorsten von Eicken. He's our CTO and a RightScale founder, and I have Dave Welch, one of our sales engineers. The 3 of us will do most of the presenting. We also have Hunter Williams across the hall who will be answering your questions. So start asking questions now. Any questions that come up, go ahead and type them into the question tab on the bottom of the GoToWebinar control panel. Here's the agenda. I'm going to do a quick introduction for the people who don't know RightScale at this point, and then we're going to turn it over to Thorsten. He's going to talk about how do you really achieve the benefits in cloud computing that everybody keeps talking about. How do you do it using machine images? And then how do you do it using ServerTemplates? Then Dave is going to show us a demo along the way, and I'm going to wrap up the final part talking about how we actually quantify the benefits using some data that we've gotten from a research paper we've been working on. And then whatever time is left, we'll open it up for live Q&A. So go ahead and start your questions now, and then we'll pull some of the more broad-reaching questions, and we'll open those up for discussion. I think we're actually going to open it up kind of halfway for discussion, and then we'll open it up again at the end. So let's just start with a quick introduction of RightScale. For those of you who don't know us, we have been helping our customers move on to the cloud and leverage the cloud for over 3 years now. We have 20,000 users, over 800,000 servers we've launched in the cloud, and you can see that we have a wide range of customers, from large pharmaceutical and media companies to small Web 2.0 startups. Our platform is software as a service, so there's no software that you need. And we have an incredible professional services team trained up and ready to help our customers move on to the cloud and then help them as problems arise. In terms of where we fit, for most of our customers, the cloud actually starts with RightScale. They use us to move on to their move their applications onto the cloud, and then every day when they go to manage those applications, to monitor them, they go through RightScale. RightScale works with a range of cloud infrastructure providers like Amazon and Rackspace. We also work with private cloud technologies like Eucalyptus, and we will be working with the vCloud Express from VMware. We offer cloud-ready solutions. That's how we get our customers up and rolling fast. Our management tools and automation deliver incredible productivity gains, and I'll talk about those at the end. Everything we do, you'll see as Thorsten talks, is completely transparent. You can look into the scripts, into the templates, into all the deployment variables, see everything. So all of our users are in control of what's happening on the machines. They're also in control of their users. We can help you manage user profiles, user permissions, and we help manage the costs of cloud computing. So you can figure out how much you're actually spending. We even project out in terms of the rest of the month, how much you might spend for the month. And of course, because we work across cloud infrastructure providers, we enable portability. So with that introduction, let me turn it over to Thorsten.
Hello everyone. I'd like to start with benefits always. You're all familiar on the left with the benefits in general: on demand, pay-as-you-go, virtually infinite compute capacity, and the ability to fully automate what's happening. And most people look at the financial benefits, right? Not having CapEx, being able to expense, not having planning risks. So for this event 6 months down the road, you don't need to plan far ahead and guess what load you will have, what you need to provision. Not having success disasters where a site or service is so successful that it outgrows the capacity that's available. What we're focusing on today is really more the process benefits, what's happening within the company that is using the cloud in order to make dev and test more agile, make it more seamless, empower the end user, the developer, to really develop and test against the system that he or she needs. Making it simpler to maintain servers and have different versions and be able to go forward, backwards, and do upgrades and roll them out in a simple manner. And through all of this, really codifying the best practices that are used within the organizations about what is installed in servers, how it is installed, how it is operated, how maintenance is being performed. And really, in order to achieve those benefits, what we have found is that there's a number of prerequisites that are necessary, and that's a lot of what RightScale focused on and really how we got going. Automating all of the steps is one of the most important things, and it's not so much in this case about the automatically scaling up and down, although that's always nice and important. It's just making it such that launching servers, having them fit into deployments, is something that happens automatically, and that someone who didn't put the server together to start with can really do and be successful at day in, day out, so they can focus on what they need to achieve. It needs to be easy to use so that, again, developers can launch servers that they need with the configs they need without having to put it all together. And finally, the transparency and control is important so that the ops ops team can see what's happening and can help developers and can help others in the organization always manage what's happening. So what we found, and really what sets RightScale apart, is that we've gone beyond machine images. What we found, and it's reflected in some of the polls and your responses at the beginning, is that machine images are very monolithic. They're not modular. It's hard to take pieces and join them together. They're also opaque, right? Once you have a machine image, it's a big blob, and it's difficult to inspect or audit what's in there, change something, or do version control. And last but not least, they're large. And most of it is uninteresting, right? Most of the files are just a standard operating system install. So you may have a multi-gigabyte image, but the only thing that really did, or that's interesting, is the Apache config file. Or what's often worse is you may have two images, and they may have thousands of files that are different between them, but really the difference is that someone installed a new version of Apache, and that changed the thousands of files, and really that's not particularly interesting, the thousands of files. It's this is a new version of Apache, so you're kind of trying to find a needle in a haystack. So what we built up is ServerTemplates, and that is, a ServerTemplate is a modular building block approach where we use configuration scripts or now chef cookbooks and recipes to build up a server from its individual software building blocks. And what a server template defines is everything that goes onto a server, both the sort of software configuration management, which pieces of software get installed and where and how, but also default server characteristics like instance types or base images, etc. Also monitoring what needs to be monitored on the server and what alerts need to be configured. And last but not least, it's a template, so it's not a bundled up server. It is a template from which many servers can be instantiated. So the benefits are that it's modular, transparent, and also very dynamic and agile. What we're finding is that when we look at a server template that we use or that our customers use, actually the building blocks come from different people, different groups within the organization and even different organizations. So at the bottom, there's a base operating system image and standard software packages coming from vendors. On top of that, a lot of the config is defined by the ops team, right? The way syslog or SSH keys or the way we install Apache or use Apache in the organization. So this is really best practices and things that are common across a lot of server templates. And then at the top is more the application and the libraries. They often define more by the developers. This is really where the app that we're building gets installed, and that's much more defined and produced by the developers, often in collaboration between ops and development. So it's really from different constituencies in the organization that all of the pieces come together. Now, in terms of how do we build a server at the end of the day? How does it really run? And the answer is that what we found is that it's really beneficial to build as much of it at runtime, at boot time. So with Linux, we tend to start with a fairly minimal base operating system install, Ubuntu or CentOS base OS install. And then we apt-get or yum install the standard OS packages for the software that needs to be there and add a config. So it's really very dynamic at boot time, and the time taken for that is very minimal. So it is really nice and flexible to keep that flexibility up to the last minute. Makes it easy to change things, makes it easy to adapt and to troubleshoot. On Windows it's somewhat different because there you're not going to install SQL Server at boot time. So we find that the images tend to be bigger, have the major apps already installed, but there's always need for the custom dynamic config at boot time. So there's a lot of flexibility there, and it really depends on the use cases. So I want to move into a demo and just demo a little bit how these server templates work together, and I'll turn it over to David for that.
Thanks, Thorsten. All right. So in this demo, I'm going to show how server templates help integrate newly provisioned servers within the context of a deployment. So this is the architecture we're going to be working with. As you can see, we have a couple front-end load balancers, a master-slave database with replication, and we have a scalable or elastic server array that will scale the application tier as load is applied to the two front ends. So now let's jump into the dashboard so I can show you how it looks. So here's the scalable photo site deployment. We have the two front ends that I showed you, the master-slave database, and attached is the Rails application server array. So as the two front ends experience heavy load, RightScale will launch a new server from that array on the user's behalf. So let's take a look at the monitoring graphs to see when the scaled servers come online. So these are the pre-built monitoring graphs that you get using Collectee, which is our open source monitoring plugin, or the open source monitoring plugin that we use. So I'm going to be taking a look at the CPU idle value. So as the front ends experience load, RightScale is going to launch the application server array on your path. So as that server boots up and has to determine its role, it's going to need to be made aware of a number of things before it can become a functional piece of the group. So for an application server, it'll need to pull its code from a repository, point it to use the correct database, install and configure the monitoring, and start up all the necessary services. And lastly, it's going to need to register with the two front-end load balancers. And this spike back up is indicative of the application servers coming online and distributing the load to the new application servers. And just as much as scaling up, when the servers scale down, you need to also run decommission scripts to clean up any last-second things with the servers or to deregister these servers with the load balancer. So now I'm going to turn it over back to Thorsten to go over the dev and test demo.
Let's show the script later.
Yeah, we'll show the script later.
Okay. Slides. So I wanted to show, so that was the sales deployment, sales demo. I also wanted to show something that's maybe doesn't look quite as pretty and as clean, but it's real, which is really how we use the server templates internally. What you see here is a screenshot of our production deployment. We manage RightScale production using another instance of RightScale. It's obviously too small for you to see the details, but as you can imagine, we run lots of different types of servers, and I broke them out and annotated them a little bit on the right-hand side. And for each type of server, we run multiples for redundancy and also to handle the load. So what I'm going to walk through now is that was production on the left, where we have lots of different types of servers that are built up using different components, scripts of all of the different software packages. As we move into the staging system that we use for testing purposes, we build up the release. It's a relatively complete replica of production, but a lot fewer servers, and a couple of them are consolidated. So we take the building blocks and build new server templates with the same building blocks as production, but just combined in a slightly different manner. And then for some of the test systems, we use fewer servers still, and again consolidate the building blocks. And in the end, we arrive at a developer all-in-one server where everything is all on one server. Again, same building blocks, all put together, but of course it's much cheaper to run, and it's also easier to manage, to bring down and bring back up. So let's switch to the staging system here. I took some screenshots last night because we're making some changes today, and I wanted to be sure that we would see what we were going to see. So there was one question that came in. What do you say to CFOs who want to have predictability in their budgeting? And you see a little bit of that here, in that we actually show the costs that accrue over time. So you have some predictability here in seeing how much each of the deployments have used to date,
what the projection is for the end of the month, the prior month, etc. So you can see what it's costing and budget accordingly, or not budget's maybe the wrong word, but plan accordingly. And we've been more in a reactive mode of seeing that something's maybe too expensive and then correcting the next month. But you can also tell who is launching what and is running forever and sending a kind email saying you still need that server that has been running for 2 weeks. So if we look, so here are different deployments in the staging account. The one with the most green dots, the one we run all the time, is the primary staging system, but we have other systems for more focused tests. So let's look at the staging 1 account, switch over to that. And again, you see at the top a summary of the costs incurred so far on this month. And there's a number of servers, a lot fewer ops than in production. A couple of different types. At the very bottom, I circled is the only front-end apps that we're running this deployment. Makes it easy to update. It has a lot of the load balancing, Apache, and things consolidated on it. And that's really the same building blocks that we use in production. So if we now switch over to development, so this is a different account that all of the developers have access to. And here we have a deployment where there's one server per, basically per group, per development group. Some have multiple servers. And as you can see here from the server template name, these are the AIO all-in-one servers. So everything, all of RightScale, all put together on a single server template and single server. These are used, you see on the right, a bunch of running, some just a few hours, some several days. Many are stopped below. And it's really under the development team control when they upgrade, when they launch, when they stop, which branch of the software the server runs. All of these things all of these are things that they manipulate, they control, so that they can make a decision, say, oh, I need to test this out, let me just launch another server, and half an hour later it's up and running and they can do whatever they need to do. So if we look at the all-in-one server template here, this is just the info. What's interesting here or to note is that this was actually published by the ops team. So the ops team is responsible for putting these server templates together. The developers can go in and look at them. And in fact, so here you see it was published by ops. If we go to the next one, this is the set of scripts that are in this all-in-one. And it's a pretty daunting list, but it is still possible for developers to go in and update something if they need to install a new version of some library, for example. So this is a pretty daunting long list here. And the thing to realize is that this is produced by the ops team. They work in this environment day in, day out. They like to really break it up into lots of little pieces. That's just the way they are most comfortable with it. It would be totally possible to consolidate a lot of the little pieces and make it a much shorter list. That really depends on the team, how the team wants to operate. And it's not completely, so first of all, you can really see what all of the pieces are and dive into them. You can also see what the differences are. So if you do a diff to the one that's running on staging, so on the left is staging, on the right, which is just the front end, on the right is the all-in-one. So there's a couple of changes. The all-in-one runs on a larger server because there's more stuff on it. Then there's additional services that on the staging system on a separate server. Here they're all jumbled together on the all-in-one. The database runs on the all-in-one as opposed to a separate server. The Marcom site we removed from the all-in-one because it's just a distraction. The developers don't need that. If you go back further down, there's a couple more things, more services, and then operational scripts that let the developers stop and start or update the additional services that are in the all-in-one. So it's what you're seeing here is also all of the not colored lines. These are all building blocks that are reused and they really come from production, or I guess in some of the cases are slated to go in production in the next release cycle. So it's really this being able to take the pieces from different servers, reassemble them, and have, so it gives both kind of the agility and control and transparency. You can really see what's in a server or a server template and modify it. It also gives consistency in that these building blocks, how we install, how we do a Git checkout, how we install Apache, how we install Rails, how we install, all of these pieces are codified in the scripts or cookbooks, and so we get a consistency. When a developer has some odd problem on the server, it's very quick for the ops guy to go in and see, oh, which new version are you running, and oh, yes, I have a new one, I saw this yesterday, let me update your server template with the new script, and then reboot it or restart a new one. And it sort of makes it very both at the same time agile, but also manageable and controllable and transparent. So before diving into how server templates work and what are in the machinery, there's maybe a couple of questions we can take here.
Okay, we can take some questions. We thank you guys for hanging in there. Thorsten is not replaceable, so as you can tell, he has a sore throat. So we're going to continue moving along. We've got him as close to the microphone as we can have him at this point. So we're going to just answer a few questions to let him take a break here. I have one. In terms of customer deployment, how much of the 20,000 is public cloud versus private cloud? So all of those are public clouds right now. We have a large project going right now to create a private cloud using the Eucalyptus technology. We're very excited about it. I'm sure you'll be hearing more about it this year. We also are working with VMware on the vCloud Express that will come out toward the end of the year. So, and we're seeing a fair amount of demand for private cloud. So I think that you know, you'll see a lot of movement there this year in terms of support for private clouds. Is that what you're seeing in sales, David?
Yeah, we're starting to see more and more larger enterprise companies looking at private cloud and a mix between private and public.
Yeah, yeah, and Thorsten has a great blog that he did. Thorsten, we did last fall, I guess, with the internal, external, public, private, looking at all the different flavors of clouds and combination of clouds that you need to consider as you're creating the cloud strategy for your company. Another question here is, how long does it take to get up and running and learn about server template technology? And I think, David, you'd be a good person to answer that one.
Sure. So, I mean, if you're already familiar with the machine image, if you're, launch that machine image, then you're going to configure that machine image via a set of scripts that you wrote out or by hand in the console. So with the server template, it's really aggregating those scripts that you created to configure the machine image, configure the AMI, and really putting those scripts into RightScripts, which we'll show you in a second, is any scripting language. It could be Bash, Python, Ruby, etc. Just with the ability to pass in inputs dynamically when the server boots up. So the model is, it is different. It provides a more modular approach, but the learning curve is not too steep when it comes to server templates.
Good.
Also, from the beginning, the goal with the server templates and the RightScripts was to make it basically function the way an average sysadmin would build if we were to ask to automate the bringing up and the booting of a server. So RightScripts is just a framework to be able to write scripts and plop them down somewhere so that at boot time or shutdown time, you can run something that does what you would be typing at the console if you were to do it manually. Using chef recipes and cookbooks is a bit more of a learning curve and more complex, and it's really appropriate for organizations that are much more comfortable with the whole paradigm and really want to have a more powerful environment to write all of the automation. So it's not one is better than the other. There's somewhat different use cases. And even if people using Chef find it oftentimes handy to just whip out a simple write script and add it in for a couple of lines of something simple. So it's really pretty smooth. We also have a large library of server templates that you can start with. So I wanted to talk about how server templates work and look a little bit under the hood. What's happening is that on the site at the top left, you get to configure a lot of properties and attributes of servers. That really all of the inputs, everything that goes into a server, starting with its identity, because the server template gets launched many times, and all of the scripts and cookbooks that need to run on it so they can be downloaded and executed. The server also needs dynamic inputs. This is the way the server template gets its personality, knows about which other servers it needs to talk to, which code branch needs to be checked out, what the name of the site is, all of these things that make the server what it is. So that gets all pushed out to the cloud, to the server in the cloud, which runs an agent, right-link agent. And someone asked about RightNet, that's the name we use for our backend communication network that allows the servers to communicate with the site and with other servers. And so that gets pushed out to the server boots, runs all of the scripts, installs all the software. And then as it is running, it feeds back information to the site. Just state updates, its server has become operational, etc., or is terminating. But also audit entries so that you can see after the fact what happened and troubleshoot it. You can go back to servers that have long terminated and go back and see what happened. Something maybe auto-scaled or a batch server ran last night for 2 hours and errors occurred. This is the way you can go back and see what happened. Also monitoring data, and you saw that already is coming back. So David, are you going to show us a little bit some of these things in action on the sales demo?
Sure, we're going to jump back into the Rails application server template. So as Thorsten mentioned, there are scripts associated with each server template that define its role. In this case, we're in an application server template. So under the boot scripts, once the server is launched, it's going to run through the set of boot scripts. For example, there's the postfix. This script is setting up the postfix mailer. Down below, we have a script that's installing Apache and configuring the reverse proxy. So let's jump into one of the write scripts for more detail. I'll go ahead and take a look at the postfix write script. And as you can see, this is just a simple bash script that's setting up or configuring the postfix mailer. You also have the ability to define inputs that you can pass dynamically upon boot time. And then some of the other things associated with the script, you can have attachments. And likewise with server templates, you have different revisions of that script or template. So let's go back into the server template, and we'll continue on with the alerts tab. So as you'll find out, there are pre-configured alerts that come with each server template. The two alerts that I would like to point out are the CPU busy and CPU idle alerts. In the first demo, when we had the servers auto-scaling, they scaled based off a certain condition. And in this case, we set two alerts to monitor when to scale up and when to scale back down. So once the condition is met, it triggers an escalation, which is an action or a series of actions, to send an email off to alert you that you're scaling up, and also to scale up or scale down the servers. Next, we have inputs. So with the scripts that we're defining in the scripts tab, the boot scripts, the operational scripts, and the decommission scripts, you can pass inputs to those scripts. So for example, here we're defining how many app server processes that we want when the server boots up. And some of these inputs are not set. And so you can define these inputs at the server template level so the common servers inherit these values. And for some of the other ones, you might need to set them at the deployment or server level to override some of the inputs you previously set. And at the top bar here, you can see that we have the different revisions of each script. So once we've made a change, we can commit it And this can kind of jump back into the dev test demo that Thorsten was just speaking to. So now once a server is launched, once that server template is launched, each server has audit entries and monitoring. So in this case, we have all the monitoring graphs, which was installed via our write script. And then under the audit entries tab, any and all actions are audited within the environment. So in this case, we can see that I was the person to launch the server this morning. And if anyone was to SSH into the server or to run a script across the server, these actions will be audited. And we can also dive in to see, what is actually going on. So we clicked on the operational summary, and so when the server boots up, we have some insight into what these scripts are doing. We're logging the stuff to the dashboard. So in this case, this is the logs that were produced when we were installing the postfix mailer. And lastly, we have a history tab. So when you're in the cloud and you launch a server, and when you terminate it, you lose all your history. But with RightScale, we contain all the monitoring and log information for each time that server template was launched or for that server was launched. So we can jump back into an older version and go and take a look at the monitoring or log graphs of each. So now we're going to jump back to the presentation. And I'm going to hand it back over to Betsy, or to Thorsten.
I just wanted to sum up a little bit. I hope what you see is that the server templates and the cloud in general really gives us a very flexible environment to operate in, both for operating, but also for all of the dev and test, and the ability to take all of these building blocks and to put servers together on demand, which doesn't just mean launching it when the load goes up. It also means when inside the organization you need a certain type of server with a certain version of the software, you can go in, pull the building blocks together, or go back to a server template or the way a server template was a few days ago, a few weeks ago, and launch the server with exactly that configuration at that time. So there's some more machinery that we haven't shown that allows to freeze. You saw the version control. We also can freeze the operating system repos. So if you're pulling from Ubuntu, you can launch a server with the Ubuntu repos as they were 3 months ago on any day or whatever, whenever you need it, so that you get the reproducibility and the server comes up the same way it came up 3 months ago. So all of this gives the automation, agility I just spoke to, the maintenance, so being able to take update like the postfix mailer script and roll it out across many different types of servers can be done fairly easily. You can also run the script on many servers on an ad hoc manner so that you can really push this out and have it set up everywhere. Finally, the transparency, it's easy to go in and to look at stuff. Right? I hate it when it's all magic and I can't look into what's happening. So we made an effort in RightScale to really bring that out and make it so that you can go in at any point in time, look at what is configured here. If you want to make a change, you can clone it and make your change and launch a fresh server with that. So it's really providing this transparency and control that is very important and goes hand in hand with enabling the agility.
Great. Okay, Thorsten, I'm going to now talk a little bit about how we start measuring some of these benefits. We've had a project going for 6 or 7 months where we've gone out to our customers and actually had them estimate how much time they're saving using the RightScale platform. The study was designed to look at using RightScale versus using cloud APIs or cloud consoles. So let me show you some of the results. We're very excited. If I can get the slides. There we go. Okay, so let's start with the impact on initial deployment. So as our customers are moving their applications to the cloud, what we're finding is that they are finding 67 to to 85% time savings using RightScale. Most of that time has to do with the fact that they can start using our server templates and our cloud-ready deployments. Some customers use these out of the box. Some customers customize them. Other customers simply use them as reference points or models for building their own. Here's what some of our customers are saying. All this research, in the research we promised that we would keep them anonymous, so I can't tell you who they are, but I can share what they said. So the first one, RightScale, gave us the ability to get up and running quickly. It would have taken 3 to 4 times the man hours to complete our initial deployment. And since we've been using RightScale as part of our solution, this is a company that develops internet services. Some go on mobile devices, but internet services over and over. So since they've been using RightScale, their new customer deployment time has gone from roughly a week to a day, a time savings of about 85%. So significant time savings as applications are being deployed out onto the cloud. What about ongoing maintenance? Our customers are telling us that they're saving about 50% in terms of just ongoing maintenance. And again, it's because these server templates that Thorsten and David have been showing you are modular, they're variable based, they're much easier to maintain. But also, a lot of this is due to the automation that they enable. There's a tremendous amount of automation in the RightScale platform. Then second is these templates and all the deployments are reusable. And what we're finding is that our customers are creating a standard deployment, a standard architecture that they can use for many different applications, and they're redeploying that standard architecture. In fact, this major pharmaceutical company is doing exactly that. Starting with an existing deployment takes the time to deploy a new application to minutes, literally a reduction in cycle time. So these companies that are using their cloud assets, redeploying similar architectures, are getting between what we're seeing are 92 to 95% savings over what it would take for them to build those deployments from the ground up on the cloud. The bottom line of all of this is that your systems administrators can do more and more. They can manage more and more servers. And how many exactly? Well, there's quite a range here. Some companies it's 1 to 50. Others you see it's 1 to almost 2,000, 1,600. This last gaming service company, the last time I looked, was running about 2,700 servers with a full-time person and part of a part-time systems administrator. So at first I thought, well, you know, this is the same application on all of those servers. It's not. They're running 20 different deployments, 20 different applications that span 2,700 different servers. So there's significant time savings, significant impact in the number of resources you need to manage those servers using RightScale. So with that, I will close out the formal portion of this webinar, and we'll answer some questions. So, Thorsten, are there some interesting ones you've seen?
Yeah, someone asked about enforcing the server template config over time on the server, and that's a very good question. And it really pertains to different use cases. So we mostly designed this to be getting the right config at boot time so that you arrive with the right things on the server when it starts. On the ops side, I find that very often a lot of the things are addressed by launching a fresh server. So that's more use case where something goes wrong. And a lot of good ops guys like to dive in and dig around and troubleshoot and why is the server misbehaving, etc. And what we're finding in the cloud is that the best reaction is actually a different one, which is let me first launch a fresh server with a known good install and go from there, because that takes care of config changes or something going wrong. It also takes care of hardware failures, etc. Then you can go in and troubleshoot so that it's something recurring, you can take care of it. Of course, there are other use cases. We have lots of customers installing Tripwire or similar software that really does MD5 checks of all of the files, periodically checks them, etc., and reports that. So that can be installed again with the server template. We're also running an in-between, which is when using Chef, the way it's designed is that all of the recipes that install and configure can be run over and over. And if the config has remained unchanged, they will just skip over it. If the config is different, they will make it right and kind of fix the configuration. So there's a spectrum of choices there. Let's see.
I have another question here. It says, how does machine image templates play together with network configurations? So with each server template, you can associate, if you're in the Amazon cloud, a security group with each server template once it's launched. If you need any other configuration files on that image, you can set those up via the boot scripts as it comes online. So is it possible to manage a clustered environment with a variable number of servers? So RightScale it's built to manage a system of servers rather than individual servers. So if we were to remember back at the deployment, we have the deployment, which is your fixed set of servers, and an array, which is the horizontally scalable set of servers that's alert-based, and based off a variable or so a certain set of conditions, you can scale those servers out.
Okay, there's a question here. Have you worked with ISVs who want to be deployed in a portable manner? Absolutely. We have a vibrant partner program. If this is a partner writing this or a potential partner, go onto our website and look at our partner program. But these partners are doing a couple things. One is that they are adding technology that our IT customers can leverage on the cloud. So they're creating server templates that are easy for our customers to get to. That means that it's easy for our customers to get to these ISV software and use it on the cloud. The other is some of our partners are indeed systems integrators, and they are helping our customers deploy on the cloud, create specific architectures that they need on the cloud. And the SIs are often also moving software, ISV software onto the cloud. So again, while the ultimate use is by IT folks, we need an entire ecosystem to support them.
Someone is asking about things that might be done by administrators in the public cloud where the server is actually living. So I think that refers to what about changes to the physical host and things of that nature. And in a way, the way we treat servers is really we start at the virtual machine level. And in a way, the cloud provider is responsible for providing a stable and consistent environment at the virtual machine level. So the physical level really almost completely disappears. And Amazon actually has done an excellent job at that, in that we have servers running for years that have a very stable environment. We can still, and when I say servers, it's virtual machines. We have server templates that we did 2.5 years ago that we can still launch, that boot and come up the same way they did 2.5 years ago. And that's because they keep a very persistent and consistent operating environment. The base machine images that we start from, the kernels are immutable. So we're booting the same bits that we did 2.5 years ago. The network functionality and environment remains the same. I think these are attributes of a good cloud. This is what a good cloud operator needs to provide. And obviously there's questions about what do they do under the hood. And as far as possible, I don't really want to know. Where it gets a little bit into the gray zone is when we're talking about security and you need to make audit statements about physical control over the infrastructure. And that's really a contractual issue or topic between the cloud provider and the customer at that point. And I think that's really more at that level of contractual and audit statements, etc., more than an operating question.
Great. I think David found another question.
Are there tools / procedures for migrating a deployment from US East to the US West region? So with the server template, as Thorsten mentioned, it starts with that base image, and everything's configured dynamically with a set of boot scripts. So, migrating between US East and US West, in the background, it's using two different images, one for the US East and one for the US West, but you have the ability to launch those server templates in different regions, and it'll just be configured in a very repeatable fashion between those regions, and also between cloud providers.
And we're actually introducing a new feature which we call Multicloud images at the, mid-month, where we can put different individual images in different clouds or regions and wrap them into one container so that they look like one image. And then the server template can point to one of these base multi-cloud images so that you can launch the server template in any of the clouds or regions for which there is a physical base image available. So it makes it easier and more transparent to operate in the different regions of Amazon EC2 or in different clouds for that matter. Someone asked about the capability to distribute the cloud-intensive aspects of an application on demand across multiple servers with real-time load balancing, and that's a very standard setup. And in fact, the sales demo uses that. It has load balancing front ends that distribute the load across a set of static backend or static app servers, as well as the dynamic launch on-demand app servers that get added in the array. So that's a very, very standard. Similar standard use case is off of a backend queue. So whether it is more batch, where there's a long list of jobs to be worked off of, or whether it's more dynamic, where maybe there's a website where users upload or create tasks that go into backend queue, and then that get worked off by a set of servers, and that array of servers gets scaled dynamically. So an example is Animoto, where they produce videos on demand. As more users are uploading videos and the queue grows, they automatically, or RightScale automatically launches more servers in order to keep the SLA constant.
Great. I think that's about it for the questions at this point. We'll leave we'll leave you with the formal part, but if there are more questions, keep asking them in the question window in the GoToWebinar control panel. But we hope to see you again at one of these webinars. If you're interested in a free developer account, go to our website /free trial, or just go to the website and you can find it quite easily. If you would like a private demo, give us a call or email sales@RightScale. And this, as all other webinars, will be loaded up on our site and the webinar archive within the next 24 hours. So we thank you so much for listening and staying with us.